Hello guys, this video is about how to evaluate limits numerically. Last lesson was about evaluating limits graphically. This is about evaluating limits numerically. The first thing I always try when I face limits is trying to plugging in direct substitution. So no matter what my limit is, I always try direct substitution. If substitution works, it succeeds, I'm happy. If not, if it fails, we will use different techniques which we will learn in the following lessons. This lesson is all only about substituting. So let's take a look at some rules. As always, we have a couple of rules. The first rule: limit as x approaches to a of c is equal to c. Since there is no x to be replaced by here as a function, the result is itself. So whenever we have a constant function here, result is going to be itself, the same constant function. Limit as x approaches to a of c is equal to c. For example, limit as x approaches to 3 of 5. I don't care what I have here as x. Regardless of what x I have, it's always the number written beside limit, which is 5 here. Similarly, limit as x approaches to 6 of pi is itself, which is pi. Result is not 6. X is the value of x doesn't matter here. The function is constant. Result is the same constant function. All right. But when we have x as a function, x in the function right beside the limit, then we will replace the given x value with the x in the function. For example, the second rule: limit as x approaches to a of x is equal to a, because you should replace your x with a, the value of x, which will give you a. Similarly, no matter what function you have, you may have an exponential function, logarithmic function, radical function, rational function, it doesn't matter. We always plugging in. So let's plug in a. So when you put a for x, it's gonna be a to the n. Similarly, when you plug in a for x, it's gonna be nth root of a. So actually these are only one rules. It seems there are 4 different rules, but the idea of all of them are same. Let's consider this as one rule. It is substitution. So let's take a look at the following related examples. There are some exercise questions. Limit as x approaches to 1 of 5 minus 6. So all you have to do is replacing x with 1. So 5 minus, in place of x, we will be writing 1. 5 minus 1 is 4. It's pretty simple. Similarly, x cubed becomes 4 cubed because the value of x is given as 4. So 4 cubed is equal to 64. Similarly, substitute 2 for x in this radical function. So in place of x, you write 2. 2 cubed minus 4. 2 cubed is 8. 8 minus 4, which is 4. Square root of 4 is 2. Alright. Another radical function question. There is a cubic root. It doesn't matter what type of function we have. We always plug in. Let's plug 21 in. So cubic root of 21 plus 6, which makes 27. What is cubic root of 27? It is 3. Okay, these are first set of rules. I can say there is only one rule here. The second set of rules: suppose that c is constant and the following limits exist. Limit as x approaches to a of f of x and limit as x approaches to a of g of x exist separately. In this case, we can evaluate the limit as a sum inside the same limit and separately. Also, we can add or subtract them separately. Similarly, we can multiply them or divide them separately. Let's suppose we have f plus g or f minus g inside the same limit. It's like uh, distribute the idea of limit through the bracket. So this becomes, when you distribute limit, it becomes limit as x approaches to a of f of x plus or minus limit as x approaches to a of g of x. It also goes for multiplication and division. Similarly, when there is a constant inside, you can pull this constant out in front. So it becomes c multiplied by the limit as x approaches to a of f of x. We don't always apply these properties unless we are given the value of the limits of each for each function separately. For this kind of question, we apply these properties. Otherwise, we don't use these properties. We don't have to expand it. We can add the functions or subtract or multiply or divide functions together and then substitute the given x value. Doing this makes the process longer, but for some questions it's necessary, like this exercise question. So for example here, what do we need to do? The first question tells us to evaluate limit as x approaches to c of 5 times g of x. I have a constant here. I don't know what g of x is. What I know is limit as x approaches to c of g of x. As separately, I don't know what g is. With limit, I know the value. So I need this written as limits. So I should get rid of this 5. So let's pull this constant out in front by using the property 5 in front multiplied by limit as x approaches to c of g of x. Now I know the value of this limit. What was the value of the limit as x approaches to c of g of x? This was given as 3. So I write 3 instead. So it's going to be 5 multiplied by 3, which is equal to 15, right? So this is the answer. What about the other one? The addition one, the sum of these two. I don't know what f, I don't know what g separately are, but I know their limits as x approaches to c. So I need to get limit. So I kind of distribute the idea of limit inside the bracket. I will write this as limit as x approaches to c of f of x plus limit as x approaches to c of g of x. Now I know the values of each limits. I know limit for f, which is 2. I also know the value of the limit for g, which is 3. 2 plus 3 makes 5. Alright. Same goes for multiplication. Distribute the idea of limit inside the bracket. So limit as x approaches to c of f multiplied by limit as x approaches to c of g, whose values were given as 2 for f, limit of f, 2 for limit of g, and 3 for limit for g. So 2 multiplied by 3 makes 6. The last one, division. The same idea goes for division as well. So write them separately. Limit as x approaches to c of f of x divided by limit as x approaches to c of g of x. I know their values separately as limits. The f1 was 2, g1 was 3. 2 over 3. Right, pretty simple. We're just substituting the given. We have similar questions in study guide part. I will write them as homework. Okay, let's take a look at the following ones. Find the indicated limit. So here we are given a complicated function. It looks like complicated, but actually the process is not. It's pretty simple. As we did in the previous questions, we just have to insert the given x value for x. It's 1, so substitute 1 for each. So 2 times 1 cubed minus 5 times 1 plus 2. So here we have 2, here 5, 2 minus 5, negative 3, plus 2, negative 1. Alright, here we have trigonometric function. The same goes for every type of function. We just substitute pi over 2 for x for each. So it becomes pi over 2 multiplied by sine pi over 2. Do you remember what sine pi over 2 is? Pi over 2 means 90 degree. Sine 90 degree is 1. So 1 times pi over 2 is pi over 2. Last one here. There is a rational function. The same process. Plug in 2 for x. So it's going to be 2 plus 2 over 2 minus 1. 2 plus 2 makes 4. 2 minus 1 is 1. So the answer is 4. Alright. So these were second set of rules. Third set of rules. It's like the second set. We may have exponential functions, square root functions. No matter what kind of function we have, we can apply these rules. So limit as x approaches to a of f of x to the power of n. So as we did in the second set, instead of using this n as a power inside, we can pull this power out and use it as a power of limit. Okay? Instead of writing f of x to the power of n, we can write limit as x approaches a of f of x to the power of n. So we can pull this power outside of limit. Similarly, we may have the square root function. So instead of using n as an index for the function inside, we can use n as an index for the limit. We can pull this out. Okay, we can pull this power out. We can pull this index out. Let's take a look at some examples related to this. Now the same idea goes for composite functions. Here we have a composite function. We can take this outside function outside of limit. So let's take a look at these exercise questions. We are given limit as x approaches to c of f of x. The value of limit as x approaches to c of f of x as 27. So as in the second set, I don't know what the value of f of x is. What I know is the value of f of x for limit as x approaches to c. So I need to get this limit in this form, in this simple form. How do I get this complex limit in the simple limit form? By moving this radical out. Let's move this out, pull this out. So instead of using this radical inside, use this radical outside. Doesn't make any difference, but it will help us solve the question. So let's pull it out. Write this as limit as x approaches to c of f of x. So no more root inside, root is outside. But I know the value of limit as x approaches to c of f of x as 27. The inside is 27, outside we have cubic root. So I know what cubic root of 27 is. It is 3. Alright. Same idea here. I have a power. I use this power as a power of limits. So use this 2, the power, as power of limit. It becomes limits as x approaches to c of f of x. So now limit is simple, just like the given limits. So whose value is 27. So it becomes 27 squared now, which will be 729. All right. The part, the same exercise question, and it was asked as in ministry exam question also. Same idea here. Power is 2 over 3. Pull this out. Simplify this, isolate this limit. Limit as x approach to c of f of x. Get it alone and pull this exponent out. Use it as an exponent of limit. You know what this limit is? Its value is given as 27. It's going to be 27 to the power of 2 over 3. After this point, you have two different techniques. First way after this point is using simplification techniques that you learned in grade 10. Maybe some of you will remember. This is writing 27 as 3 cubed, and the outside power is 2 over 3, right? So I have 3 at the top, 3 at the bottom. They will cancel each other. I will be left with 3 squared, which is equal to 9. All right? The second technique is using your calculator. When you use your calculator, most of the students are making mistake here by typing this in the calculator. What you need to do when you type this in calculator is write 27 to the power of 2 over 3 in the bracket. Otherwise, your calculator will, if you don't do this, if you don't put bracket, if you write this like this, 27 to the power of 2 over 3. This is what your calculator will do if you don't use this bracket. So that's a mistake, a big mistake. So never ever do this. Whenever you have fraction as a power, you use parentheses around. Okay? Whether you use the first way or second way, as long as you use it correctly, you'll get your answer. Okay, we are done with third sets of rules. And that's it. We finished the rules. Let's take a look at the last question, a ministry exam question. We have a composite function. We are given function f. We are given a g function. Then we are asked to find limit as x approaches to negative 2 of g of f of x. We can use this rule. We can pull this outside function out and use limit with the inside function. You can pull this g outside and use this limit as for inside function. So this is g of limit as x approaches to negative 2 of f of x. So what is the function for f? It is given as, let's take a look at the question. This is given as 3x squared minus 2x. So we get back to the same point. We have substitution technique. That's what we learned. We don't need another technique. Substitution works, so we do direct substitution. Substitute negative 2 for x in f function. So here we have negative 2 squared, 3 multiplied by negative 2 squared minus 2 times negative 2, which will make 4 squared, 4 times 3, 12, plus 4, 16. So what I need is g of 16. So what is g of 16? Now let's go to function g. Use function g. I am done with function f. So g of 16 is equal to cubic root of, substitute 16 for x, 16 minus 8, which is 8. With this cubic root of 8, that is 2. So the answer is B. Okay. Or without using this rule, taking G out and using limit for inside function and stuff, you can basically use evaluating functions technique. Let's consider it's not limit, it's evaluating functions. You evaluate this as, let me write this as a second way. Let's say this is second way. Since limit is kind of evaluating functions, is like evaluating functions, if evaluating works, substituting works, we can use this always. So instead of doing this in a long way, you can find g of f of x. Remember what x was here. Your x is given as -2, so all you have to do is insert -2 for x. So substitute -2 for x. So find g of f of -2. All right, that's it. You do the inside function first. Remember from the first chapter, you do the inside function first when you have composite functions. What did we find for f of -2? We found 16. Now do the same for the outside function. Now insert 16 for g. It will give you cubic root of 8, which is 2. All right. So that's pretty much it.